This is going to be an introduction to functions, and a lot of what we're going to do is going to be graphing. So let's first look at what a coordinate plane is. A coordinate plane is actually an intersection of two number lines. Okay, we call these the axis. This would be your x-axis, that's your horizontal number line. This would be your y-axis, that's your vertical number line. And this point right here is the origin. Okay, that's at 0 on both of those number lines. Now, points on a coordinate plane are described by using an ordered pair. It's called an ordered pair because it has a specific order. The x-coordinate is your first number, and the y-coordinate is your second number. The x-coordinate is your movement on the x-axis, so that tells you how far to the left or to the right from the origin you move, whereas the y-coordinate is your movement on the y-axis, which tells you how far above or how far below you move. Okay? So the first thing we're going to do is we're going to plot these points on the coordinate plane. We always start at the origin. That's the beginning point right here. Okay? So this first point T is -4, 4. So remember that first value tells you how far left or right. So -4 would be 4 places to the left. And the second number tells you how far up or down, so that would be 4 places up. So that is point for -4, 4. The second one is 0, -5. So the 0 tells you not to move left or right at all, to stay right there at 0, and then go down 5 spots. So that would be you right there. And the last one is -2, -3. That's 2 places to the left and 3 places down. Okay. Now again, remember we always start right here at the origin, which has the coordinates 0, 0. Okay. Now we're going to name the quadrant. Now quadrant means like a quarter, 1/4 of the coordinate plane. So we're going to name these quadrants. I tell kids to raise your right hand and make a C for the coordinate plane. That's how the quadrants go. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? So E is in which quadrant? Again, if you compare this, that's quadrant 2. F is in which quadrant? Well, it's not. It's on the line. G is in which quadrant? Quadrant 1, and H is in quadrant 3. And you'll notice that quadrants are designated with Roman numerals. Okay. An equation has two variables, and you can use it to write a rule to come up with some ordered pairs. We let the x value be our input. That's the value that we're going to substitute in for. And the y value is going to be our output. Now, these are some names. The dependent variable is your output. That's your y. The independent variable is your input. That's the x. In a function, the value of y is determined by the value of x. And if it's a function, every x value that you put in can only result in one y value. All right? So, here's an example. We've got a word problem here. An engraver charges a setup fee of $10 plus $2 for every word engraved. We're going to write a rule for the engraver's fee. Then we're going to write some ordered pairs when there are 5, 10, 15, and 20 words engraved. So the engraver's fee, y, again, that is your dependent variable. That depends on what happens here. The word is equates with equals $10 plus $2 for every word engraved. So every word that engraved is our variable because that's what changes. Okay? So y equals 10 plus 2 times x, and we can write the rule like this. Okay? Then what we're going to do is we're going to figure out a set of ordered pair when there are 5, 10, 15, and 20 words engraved. We're going to do this with a T-chart. This is X, this is Y, 5 words, 10 words, 15 words, and 20 words. So if I know that the x value is 5, I'm going to take that and put it right here. So 2 times 5 is 10. 10 plus 10 is 20. So when I put in a 5, I got a 20. When I put in a 10, 2 times 10 is 20. Plus 10 is 30. 15, 2 times 15 is 30. Plus 10 is 40. And 2 times 20 is 40. Plus 10 is 50. And I think that you saw a little pattern happen there. Okay? What I just did here, this is what I like to call my function machine. They gave me some values to put in here. So I started with a 5. So the 5 came into the function machine and went right here in place of, I bet I can rotate that a little bit. Oops, wait a minute. Okay, it's going to go right there in place of the x. And then I'm going to work it out. 2 times 5 is 10. 10 plus 10 is, so this magically turns into a 20, and that is what comes out. This is what goes in. This is what goes in. This is what comes out. This is my input. This is my output. We also said this was our independent variable. This is our dependent variable. In math, we said this was x, this was y. And just to throw you a loop, I'm going to give you another word. We call this our domain, and we call this our range. That's a lot of good stuff there. Okay? Another way to do this, instead of like the little function machine, is I did it with a T-chart at the beginning. This is an H-chart. Now, an H-chart is kind of an alternative to a T-chart. It just gives you a place to do your work. So if I put a 5 here, then I would actually put my work here and my answer over here. Okay? 10, 15, 20. Again, this just gives me a spot to do my work. Oops. Okay? So just a place to do my work. Okay? Alright. These represent ordered pair. The ordered pair here would be put in a 5, get a 20. Put in a 10, get a 30. Put in a 15, get a 40. Put in a 20, get a 50. That was supposed to be a 50, not a 5. Okay? When you graph these ordered pairs of the function, you should get some kind of pattern. And that's what we're going to be looking for now, are patterns. So you'll see here's kind of the T-chart right here. This one says that the equation is y equals 2x plus 1, and they want you to use the values -2, -1, 0, 1, and 2. And you can see how they're just substituted right in here in place of the x. Do the work. So a -2 went in, a -3 came out. -2, -3 is this dot right here. A -1 went in, a -1 came out. There's this point. 0, 1, 1, 3, 2, 5. Notice what that forms. That forms a line. Let's look at this one. This equation looks a little different. It has an x squared in it. So I put this in. Now you'll notice when you substitute this in for the x, it automatically goes in parentheses. So -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. See how these points are generated? When you plot these, I see a different shape. This is more of a U shape. Here's another one that's a little bit different. This is an absolute value sign. So I substitute in here. Absolute value acts as a grouping symbol. So 0 minus 2 is -2. Absolute value of -2 is 2. Put a 1. 1 minus 2 is -1. Absolute value of -1 is 1. See how these points are being generated? Again, when I plot these points, I see a different shape. That's a V shape. As we work through the functions, it's going to be really, really important that you look closely at the equation, look at its characteristics, and then look at its graph and look at its characteristics. you're going to start being able to determine what the graph's going to look like before you've actually graphed it.